The effect of word sense disambiguation on linguistic regularity and classification accuracy of word embeddings. Word embeddings encode the semantic and syntactic meaning of words into a distributed vector representation. Many consider the skip-gram method of word-to-vec introduced by Mikolov et al. To be the gold standard when it comes to word embeddings. The gold standard moniker, however, is less about accuracy than it is about the efficiency of that method. Word2Vec builds a single vector representation for each word in a vocabulary. For example, the children play together and we saw a play Friday night. Word2Vec will combine both meanings of play along with any others that exist into one single vector. The research question for this project is, does Word2Vec accurately represent multiple senses of words? Trask, Michalik, and Liu attempt to resolve the superposition of meanings by disambiguating each sense into a separate vector embedding. They do so by using supervised natural language processing labels, and they call this sense2vec. Part of speech is the most obvious labeling to use to disambiguate word senses. In the example below, you can see that play in the Word2Vec model is most clearly represented as a verb in the top 5 most similar words, whereas sense2vec can easily disambiguate between play as a noun and play as a verb. We can measure how good the Word2Vec and sense2vec word embeddings are by analyzing the linguistic regularity of the word embeddings. We do so by using syntactic and semantic analogic reasoning tasks. The dataset used is the large movie review dataset from Mass et al. With 100,000 movie reviews. In syntactic analogies, Word2Vec performs significantly better than sense2vec, which is a surprising result. As an example of a syntactic analogy, make is to makes as play is to plays. As you can see, in general, Word2Vec is performing much better in both the top 1 and top 5 results. In terms of semantic reasoning, in which an example might be man is to father as woman is to mother, the sense2vec model performs slightly better than Word2Vec. Here we are testing 79 unique categories of analogy from the SEM Eval 2012 Task 2 from Juergens et al. We also test classification accuracy using a convolutional neural network based on the work of Kim in 2014. We attempt to predict whether a particular sentence will be part of a positive or negative review. However, both Word2Vec and sense2vec perform poorly on this task, so more work is needed in the future. In conclusion, Word2Vec performs noticeably better in syntactic meaning, which is a surprising result. Word2Vec performs slightly worse in semantic meaning, but the difference is small. More work would be needed to determine the effect of sense2vec on classification tasks. Finally, sense2vec requires an additional supervised training step in order to tag words with part of speech. This increase in complexity of the model would need to be met with a significant improvement in accuracy for sense2vec to make sense as a model that data practitioners should use. Thank you.